Welcome to Future Dr. NEET Academy for the problem solving session in Physics, NEET Physics. Topic chosen today is from chapter 13, Oscillations. And this session is not problem solving session, problem questionnaire session. That is, 7 questions will be sprinkled in this session, and next session we are going to solve the solution for this question. Let's move to first question. The phase difference between displacement and acceleration of a particle in a simple harmonic motion is dash. A option 3 pi by 2 radian. B option pi by 2 radian. C option 0. D option pi radian. Here we should know the relationship between phase difference, displacement and acceleration of simple harmonic motion. By knowing the formula, you are able to derive the solution for this question. Let's move to question number 2. A particle executes linear simple harmonic motion with an amplitude of 3 centimeter. When the particle is at 2 centimeter from the mean position, the magnitude of its velocity is equal to that of its acceleration. Then its time period in second is dash. A option root 5 by pi. B option root 5 by 2 pi. C option 4 pi by root 5. D option 2 pi by root 3. That is, by knowing the relation between time period, acceleration of the particle and all, and amplitude of the particle, displacement of the particle, you are able to find the solution for this question. Let's move to question number 3. Two simple harmonic motions of angular frequency 100 radian per second and 1000 radian per second have the same displacement amplitude. The ratio of their maximum acceleration is dash. A option 1:10. B option 1:10 power 2. C option 1:10 power 3. D option 1:10 power 4. That is, by knowing the relationship between acceleration, displacement amplitude and with angular frequency formula, you are able to derive the solution for this question. Let's move to question number 4. A particle executes simple harmonic motion of oscillation with an amplitude A. The period of oscillation is capital T. The minimum time taken by the particle to travel off of the amplitude from the equilibrium position is dash. A. T by 4. B. T by 8. C. T by 12. D. T by 2. Here what you want to find? There is a period of oscillation T is given. So you should know the period of oscillation T value. Formula for T we should know in terms of amplitude. By knowing the formula, you will derive the formula for this question. Let's move to question number 5. In a simple harmonic motion, when the displacement is 1/2 of the amplitude, what fraction of the total energy is kinetic? Option A 0. B option 1/4. C option 1/2. D option 3/4. That is, here we should know the formula for total energy and kinetic energy of the particle in terms of displacement or amplitude. So by knowing the value or the formula, you are able to solve this solution. Let's move to question number 6. A body executes SHM, that is simple harmonic motion, with an amplitude A. At what displacement from the mean position, the potential energy of the body is 1/4 of its total energy? A option A/4. B option A/2. C option 3A/4. D option some other fraction of E. That is, you should know the formula for potential energy and total energy. Then, by knowing the formula and finding the relationship, that is ratio, you are able to find the solution for this 6th question. Let's move to last question, 7th question. The time period of a simple pendulum is 2 seconds. If its length is increased by 4 times, then its time period becomes dash. A option 16 seconds. B option 12 seconds. C option 8 seconds. D option 4 seconds. Here you should know the formula for time period of the simple pendulum. By knowing the time period of simple pendulum with respect to length and G, you are able to find a solution for this question. So in next session, we will solve the solution for this question. Thank you.